Okay, here we are, the very end, 9-5, day 3. Okay, nothing new in this section, just a mishmash of everything. So I've got 3 examples for you. First one, and if you remember the rules, it's odd powers of sine and cosine, even powers of secant and cosecant, and then the sine squared and cosine squared were the 3 new ones in here. So our first one, we'll see if you can pick out which rule you should be following. I've got tan to the 6th of 3x times secant squared of 3x dx. And if you look, it's an even power of secant, so I'm going to start there and see where it takes me. And the process with that was take a secant squared, which is all I have, slide it next to the dx. If there were any secants left, I'd write them as powers of 2, but there's not. So I should be able to just attach this to the dx and do a... And to see the power rule, I like to see the inside and outside. So the inside is tan 3x, and I know the derivative of tangent to be secant squared 3x, also times the 3. If you need to put that derivative on, but if it's helpful, the derivative is secant squared 3x times by 3. So we still need the 3 here, so you need the 1/3. So when we integrate, the 1/3 carries. Then it's power rule, where I add 1 and multiply by the reciprocal. So it's tan 3x to the 7th times 1/7 plus c. And there it is, 1/21 times the tan to the 7th of 3x plus c. Okay, next one. Got the integral of 1 plus tan squared x dx. Okay, if I run through my rules, it's not odd powers of sine and cosine. It's not even powers of secant and cosecant. It's not a cosine squared or a sine squared, so it's got to be something else here. But boy, this kind of looks familiar to me. As a Pythagorean identity, maybe I simplify first. Maybe, just maybe. 1 plus tan squared. 1 plus tan squared does equal secant squared, so I can just simplify that and rewrite it as secant squared. So I've got the integral of secant squared x dx. Okay, at this point, I have to ask myself, is there something that has secant squared as its derivative? Even though there's an even power of secant here, I don't have any tangents with it, so it's not the even power of secant that I can use. So, oh yeah, right here. Tangent's derivative is secant squared, so the antiderivative of secant squared is tangent. So this integrates right to tangent. So maybe simplify first. You do have some trig identity ones. I'm going to tell you they are numbers, I wrote them down, 25 and 26 on the homework. What you're going to want to do is use a Pythagorean, not a Pythagorean, some kind of a trig identity to start with. I think they are Pythagoreans actually, to simplify first, and then it'll be something you know how to integrate. Okay, third one. We haven't had this yet. Something to a negative exponent. Cosine to the -2 of 6x dx. Well, first thing I want to do is rewrite it so it has a happy exponent. That would be 1 over cosine squared 6x dx. Okay, well, 1 over cosine is secant. So this is secant squared of 6x dx. Oh, and I just had that. There is a trig function that has secant squared as its derivative. And that is tangent again, but I need the derivative of the angle over here to do that. So the derivative of the angle, because there's an inside function, it's the angle here. Back here it was just 1, so there was nothing to worry about. But here I see that 6, I automatically know anytime I'm dealing with the trig functions, I need the derivative of the angle attached to the dx. So now it just becomes 1/6 tan 6x plus c. And you can check the derivative, carry the 1/6, Derivative of this is secant squared times by 6. The 6 and the 1/6 cancel out. I'm right back to that. It's all good. Okay, that's really it. It's just keeping track of everything now. There's nothing new other than maybe simplifying first with this trig identity. Oh yeah, there are a couple. They tries to sneak one in here on you, actually a couple, where it's just the integral of a constant. And we know that the integral of a constant just goes to the constant times x plus c. Like if that was a 1 there or a 5. So he's looking to catch you on somewhere in this assignment where it looks like it should be something you need to integrate, but it's actually just a constant. So see if you can pick up on that in the assignment today. Our last assignment, page 454. Where is it? 19 through 28, 31, 32, and 35. Okay, that's it.